The shop is open. Hey guys, welcome back to the TV shop. It's Saturday morning, September 13th. Nope, I'm sorry, September 16th. Boy, am I behind. Been sitting here watching Bob Anderson doing a restoration on a Dumont Rumson. It's part one. Very interesting. Very interesting what they did with that old set. He said that was 1948, I think he said. One of the earliest TVs that they made. Very interesting. So I'm out at the shop, as I've said. Everything's where I left it. But I decided, I'm kind of bored, I want to make a video. I'm not ready to tackle that guy. But here's what I got. I got the old RCA phonograph / AM radio. Rca Victor. And I know I made a video on it, I think I did. So I'm going to try to take this thing back apart, pull the chassis out, of course. Let's see if we can hopefully have enough parts to make this thing work. And then once we get the radio working, we'll clean the cabinet real good, polish it, and we'll take the changer and find out what it's going to take to fix the changer. I may have to order some parts off of eBay, so this is not going to be just a one episode deal here. So anyway, let's see if I can remember. It's a model 4-Y-511, chassis number RC1134. I do have the print for it. So can't stand around here gawking and looking. But I guess we'll look at it. I love the case. The case is a little grimy. We're going to take a little bit of work on this case. It's a Bakelite case, of course. You know, if I remember right, there's no flaws in it. I think there's a scratch right over here. A little bit of rust. Or a little bit of tarnish. I'm not sure if this is supposed to be this color or is that tarnish. I'm not sure. But the hinges are really good. Even the line cord's still good. It's got this old hardware store plug on it right here. Case seems out of alignment just a little bit here. It's canted over this way just a little bit. We'll have to look at that too. So anyway, let's get this thing out of the chassis here, if I can remember how to get it out. So, do you want, I'm trying to decide, do y'all want me to put you guys on the tripod, or just take the thing out? Let's look at it. Let's do that. Y'all working on one of these things, you'll figure out how to open it up. If you can't figure out how to open it up, something this simple, then you don't need to be working on it. So, not trying to be gruff or nothing, but I'll bring you back and get this thing apart. Going to be a booty this morning. One-handed operation. We'll try my best to keep you guys the object we're working on in the center of the frame. Got that new editing software I really like. It's got a lot of bells and whistles, and I was surprised to find out how powerful it actually is. It just takes a learning curve to do it. But for my channel, this little old simple little radio TV repair electronics channel, I'll learn it as I go. I can't learn it all at one time because my mind just ain't that smart. But I'll get it all figured out. Anyway, I'm taking the screws out of this section right here. This is the tube access panel right here. Take those two screws out and it just lifts up. As you can see, it's in pretty decent shape. We'll put that over here, and I'm gonna let my coffee from Denny's protect it. Now we can see the chassis, and I believe I pulled all the tubes out, so we're good there. So now I got to remember how to get to that. So I see my battery indicator starting to warn me. I gotta get my carpet to protect it. God almighty! Get out of there! Why do I put stuff where it don't need to be? Alright, hang on a second here. De-shaky cam, you guys. Flip this over. Something rattling around in here. Alright. I should have had this battery charged. Okay, let's see, what next? Here's the chassis. I think this piece here comes off next, so I'm just going to get y'all in frame. There's one. There's two. And being this is Bakelite, guys, if you're not familiar with Bakelite, it's a primitive early plastic. And it's very super fragile. Well, taking the screws out, no big deal on this stuff. But when you go to put this stuff back together, do not use a power tool. Use your manual screwdriver and feel. And what you want to do is, you can look in there, the threads are into the Bakelite, so you want to start the threads when you go back together with it. Get that magnet real crazy. Put it in here with your fingers, find the hole, turn it backwards till you feel it drop. In other words, use your fingers to start it. When you feel it start easy, then you can screw it down with a regular screwdriver. If you don't, you're going to strip out those very fragile threads and also break that Bakelite in there. And we don't want to do that. Alright, I got this screw, this screw, this screw, and this screw out. So I got the phono player disconnected. So all that should be good. So let's see if I can lift it out. Kind of like, and there it is. So let's just move it over here out of the way temporarily. Look at the bottom. Here's the phono, and there's somebody I saw online that has the replacement pieces for this, like that idler right there. That thing is gone. And here's the idler right here. Here's the change mechanism. That's all gone. That's all really just super deteriorated. So we'll have to take all this apart and clean it. But I'm going to see if I can find an RP190 rebuild kit. Now I think I saw somebody doing that stuff on eBay. Anyway, let's get this out of the way very carefully. Try not to damage it, because that'd be just something I would do. Get that dude out of the way. Alright. Let's put this over here. Let's get the chassis out. Got to get a 1/4 inch nut driver, which I have. Exolite. Can't tell you the number. Just red Exolite. I need both hands for this. Need both hands to stabilize this radio. It's not a very extravagant, overly designed radio. It's a very simple little radio, so it shouldn't take a whole lot of parts. Filter cap. Let's see. Got to take that off. A filter cap and a couple handful of little capacitors. Hopefully I got the stuff to fix this, and I ain't got to order nothing. That's a long screw. It's a little dirty. As you can see right here, see this little wax right here? That little wax right there and a little bubble right there. When you see something like that, what does that tell you? Well, if you turn the chassis back over like it is right here, this is where it was, okay? Notice this blob right here. Well, look what was above it. This capacitor right here, these old wax capacitors. And this guy right here has spewed all their wax out. They've gotten actually physically hot because they were super leaky. They were a resistor more than they were a capacitor, which meant they were leaky, they got hot, and it's possible that that would have damaged the output tube and or output transformer, but if I remember right, we looked at that, so it's fine. So we got 1, 2, 3, 4, 5, 6 capacitors, electrolytics, not electrolytics, I'm sorry, wax capacitors to change. This looks like a line cap right here because it's a ceramic cap. It's still a wax capacitor, but it's ceramic based, outside shell instead of paper. So we got the electrolytics to do, which I think is probably a 2-section, and then 1, 2, 3, 4, 5, 6 of those capacitors. So let me figure out what I need and see what I got, and let's see if we can get this thing let's see if we can get these caps changed. Okay, as I'm now, y'all can do whatever y'all want to do, but this is how I do it. When I come to a set like this and I'm wanting to change capacitors, I just get my notepad out. And like, here's a 0.0, I just start somewhere, so I start right here, 0.047 at 400. So I'll write the value, 0.047 at 400, and I'll just put a 1 by it. Here's another 0.047 at 400. So I just put another 1. Then here's a third one right here, okay? Third, 0.047, I come over and do this. So let's just say there are 2 more in there. I would put another mark, and then another mark. That would be 5. So when I get all those values, then I go back and I find some more. So in other words, I got all 3 of these. Well, so far, we're going to need 3.047 microfarad at 400 volts. I need 3 of those. So that would be this one, and this one. So the next is this one here, which is a little bit different flavor, and you know, you can't see, as you can see, you can't really tell what the value is. Let me get you set up here. I got a mission here. Let me turn that a little bit so I don't drop my camera. That would be what I just did. Alright, I don't know what happened there. Guess I took some steel. Anyway, take you an alcohol pad and you go on these capacitors and you can just wipe them down just a little bit. I think this will work. And usually you can see the value. You just have to play with it a little bit. The alcohol softens it up and glosses it up where you can see it. Now I'm looking for the value. Here we are. Here we are. Don't know how well you can see that. I can see it. I can't see it for all the glare. I had to get a light. It looks like it's a 0.00 something. Yeah, there you go. 0.0015, I believe. At 600 volts. So anyway, 0.0015 at 600. So 0.0015 microfarads, 600 volts, 1. So alright, so now we've got 4 capacitors, capacitors. Now there's one way down in the bottom of the bowels of this thing, marked arrow box. I don't want, that's the other thing, you got to make note how all these capacitors are, okay? Take lots of pictures. Don't go in there and just willy-nilly messing with this. All these capacitors are at a certain spot. Like I disturbed this one a little bit, but you can see right here that black band right there. Let me move you in frame a little bit. This is where it was sitting on the bottom of it. So that capacitor was probably sitting exactly like that right there. But when you go and put these capacitors back in, you got to make absolutely sure that you put them exactly back in like they came out. And there's a lot of controversy or discussion about these black bands. These black bands are not polarity. These black bands is the outer foil, the outside foil of these capacitors. Now, when you go in there with a new polyester, or not polyester, the plastic film capacitors that I use, a lot of people say, oh, it doesn't matter about those. Well, okay, that's fine. If you just want to throw them in there however you want to, that's fine. But I like to err on the side of caution. And Mr. Carlson's got several videos on how to find the outer foil of these capacitors. But basically, I use an oscilloscope and my fingers. Anyway, I'll find the outer one, and I'll make a demonstration of this one more time. But they say it doesn't matter. Okay, it doesn't matter, but I'm going to do it how I want to do it, which means I'm going to locate what appears to be the outer foil of the replacement capacitor and put it back in like they say. And I read somewhere RCA tells you about, somewhere in some literature I've read, I can't tell you now where I found it, about these bands and how you replace these capacitors. A lot of RCA, I don't remember where I found it. It's online somewhere. Anyway, I got to get to that capacitor down there, that one there, and this one here. I got to get those values. So let me get those values right there, and then we'll find the electrolytic, find out what those are, and see how many of these parts we got. Let's go ahead and get the replacement stuff. Alright, now this capacitor here is an 047 at 400. We already have that marked, but what I need to do is I'm going to clip. I already know where this thing goes. I've already got pictures of it and all that, so I'm going to clip the lead right here because I need to get below that to see what that capacitor is. So I'm going to clip it right here. The reason I'm clipping it, now I'm going to just gently move it out of the way. Now I can see the capacitor down there. That way down there in the bottom. Now I can see that guy. And I can, it's a 0056. Get that light stable. I'm going to zoom you in. You see it? 0056, 400. It's probably the only 0056 in there. 0.0056 microfarad. Kind of odd value. We'll mark that 1. Okay, now I'll move this one back very gently, and I know where that one goes. Okay, so I'm not worried about that. So we've got 1, 2, 3, 4 capacitors identified. Now we got to do this guy. Now that guy is buried in there. So what I'm going to do, come back over to my trusty old and get a pair of needle nose. Alright, let's get this light back in here. And I'm going to go in here to the body of the capacitor and just twist it. I'm just twisting the body of the capacitor. Oh look, another 0.047. There it is, you see that? 0.047. And I don't care what the voltage rating is. So we come back over here to our 0.047 and make another mark. Now we have 4 of them. 4 0.047s. 1.0015 microfarad and 1.0056 microfarad. So now we've got 1, 2, 3, 4, 5 identified, 6 identified. So now we got to do this one down here on this side right here. and that's one of them that's been cooked. And let's see here, and the same thing, we got to turn the capacitor till we can see it. Let's see, get you in frame here. I think this is the what they call the quality capacitor. Oh yeah, this is the one that was leaking all the ooze while it. That looked like a .0047 if you can almost read it. Zoom you out. You can almost read it. Right there. Battery's going dead. I gotta pause you. Oh, that battery, it died. Anyway, it's this capacitor right here that we were looking at a second ago. That right there is from the plate of the output tube to ground, and that is the quality capacitor, as they call it in the old radios. I couldn't read the value on it, so I had to break down and look at the schematic. So the output is a 50C5, typical for All-American 5, and this is the capacitor right here, C9, which is a .0047, and that sounds right. So that capacitor is the one that leaked all its innards. So that put a tremendous strain on the output transformer. If I remember right, we checked the output transformer, so we should be good there. So anyway, we have all our capacitor values, other than the filter caps. And the filter caps right here, this is C10A, an 80 microfarad. And then let's see, here's C10B, which is a 50 microfarad. So that's the two electrolytics. So an 80 and a 50. 50 is an odd value. That's alright, we'll figure it out. 80 and a 50. Probably use a 47 on that right there. I don't know, that's probably 150 volt capacitors, if I had to guess. Let's see here. Let me guess, 150 volt capacitors. Let's see. Here's my bag of pots. Here's the filter right here. 80 and 50 at 150. Look at there. Boy, mine works every now and then. Alright, so I gotta dig through my stuff and see if I got enough to fix this radio. So let me dig through my stuff, let the battery and the camera charge up a little bit, drink a little more coffee because I ain't quite jittery enough, and answer the phone. So talk to you in a little bit, hopefully. Alright, I've got you guys in the tripod, and I debated whether or not to put this part of recapping in the video, but I couldn't hold you guys in my handheld. Couldn't hold you guys in my handheld with this guy and do this. It takes both my hands and all my eyes. So the only thing I had to do is put you guys in the tripod, and this is kind of a happy medium here. It's not super close up, but I have no way I can get you close up. So this is the best I can do. So let's start changing some capacitors. I dug through all my stuff. I got a couple of capacitors here that, like this one here, is a .0047 substituting for 0056. Close enough. I ain't saying that, but this is something that I probably never use, and I don't want to spend a lot of money on it. .001 substituting for a .0015. Again, I'm not too worried about that. Well, I just realized that's a 100 volt capacitor. That ain't gonna work. I gotta go find another one of them. But anyway, I got everything else. So let's just change what we have. And I think in this instance here, I'm not going to go for 100% rebuild on this one here. I think I'm going to the path of least resistance. And what that means is I'm going to do a hook and loop. So what I need to do first is identify the outer full of these capacitors. Like this .0047 right here. Let's go ahead. May not have gave myself enough lead. It ain't like this is easy to get to, you know. And it's not. How they built these things back then, never know. I'm going to do this the way that I can do it to reach it. Clipped it out. You can tell how hot and dry that thing has gotten. That is completely devoid of wax. You know, that's the .047 right there. I have 1,000 of them, or did have. .047 at 400 film capacitor. I'm using one of my Rcas this time. So, good opportunity to show y'all. Once again, got a capacitor. Oh, pointing tool. Hang on. Pointing tool, you got to have a marker. Take your capacitor, this guy right here, oscilloscope, put your leads on here, put your fingers on here like that. Don't touch the wires, try to keep it centered. Turn your voltage gain up. Turn your okay, here we go. You notice your trace there, you see a little bit of a trace there. Alright, note the level of the trace. Turn your scope probes around, in other words, switch to polarity. You notice how it got higher. Go back. Do it a couple of times till you're sure. That's the lower of the two. You now know, here's the negative. Where are you? Probably didn't even see it. Here's the negative. That tells me where the outer foil is. So now you just take your marker and put a dot on there. How much of that you got in the shot. Coincidentally, there's a line right there on that capacitor that coincides with the dot I just made. What are the odds of that? Now that we got that done, we'll just go in here, put y'all back where y'all were. A little bit better shot. Just make a little loop. These things are hard to get into. I'm not sure that wire's going to take solder. Reason I don't think it's going to take solder is, let me show you. That rubber right here, this rubber insulation, you see that corrosion right there? This old rubber insulation causes corrosion. It does. This decomposes and becomes acidic, and it actually causes corrosion on the leads. Do not reuse these. Anyway, I got to test solder this lead and to see if it's going to take solder. I may have to go ahead and no, it's not taking solder. That sucks. Means I got to do it the old-fashioned, the hard way, should I say. Not sure I'm up to this today. Yeah, I really ain't sure I'm up to this today. Got a lot of distractions going on. In my life this morning. This may force me a lot of times what I like to do is I like to heat the lead just enough to where when you take your soldering iron off of it that it still wiggles after the solder. That means you've got it partially unhooked. So I've got to turn this around a little bit, figure out how they ran the leads on this. Once you get it unsoldered, when it's wiggling like that, you gotta be very careful though. You want to break nothing in these tube sockets. These things are probably 60 years old. I wish you could see what I was doing here, what I'm trying to explain to you. I'm getting there. You can see everything is wiggling. Remember, the solder is 60 something years old. It does become a little bit brittle. It crystallizes just a little bit. I have it loose now. And one side of it's got a little blob on it, but I'm going to cut the other side, and I got to make note of where that just flew. Sometimes it's just a battle that you just have to take your time. I've got a hole walled out for it if I could just heat it enough to get it out. There. It's a battle, but I have a hole now that I can reintroduce this thing. Now I got to do the other side now, which is going to be even more fun because it's even more buried down in there. That's the only thing that I don't like working on. One reason I don't like working on these little old things. It has that plastic spaghetti on it too. Remember, that's got to go. You don't keep those. You don't reuse them. You don't, oh gee, that's pretty. None of that stuff. Again, I'm going to try to do the same procedure. Oh, and I've got to replace this resistor. This carbon resistor just broke in half. I think it's a 33 ohm resistor. A lot of solder just fell off. There we go. Couldn't believe that. Lead actually came out. Boom. Now to pull the resistor out. Boom. So, looks like we're going to be able to do that properly after all. That resistor come out right here, so I got to pull that off too. Look like it's gotten hot. The reason it's gotten hot because they were using it with the shorted capacitors in it, drawing a lot more current than it normally should draw. This here comes right off the line. They will get it out too. Look like it's been replaced before. I'm going to take a little bit of solder wick, hold of it. See if I can clean that up a little bit. I think I can deal with that. Alright. Let's put the 33 ohm resistor in there first. And if you didn't see the resistor, this is it, right? What's left of it right there. It's got an orange band on the end, so it means it starts with a 3. Yeah, it's R12 right here. 33 ohm resistor, half watt. So let me go dig through my junk, see if I got a resistor. Alright, well I have 30 ohms and I have 39 ohm resistors. Now these resistors I've got are pretty old. So let's see what the actual value of this thing is. 32.4 ohm. Perfect. I figured it's going to drift up high. So we got a 30 ohm resistor that's identifying as a 33 ohm resistor. Okay, so let's put that dude in first. Somehow. We're just going to manually do this. Kind of guesstimate at the lead length. Find my needle nose, wherever they might be. Lights in y'all way. Yeah, I know, I'm moving this around a lot, ain't I? See if I can get this one in there. I'm gonna get that in there, but yeah, it's almost fitting. Well, is it gonna fit? I think I'm getting it in there. Oh yeah, I got it in there enough where I can make a good mechanical connection. Alright, put a little splash of solder on that bad boy. It's a fresh 21st century solder. Yeah, I guess that'll work. It'll work till it don't. Big old blob of crystallized solder. Alright, just forming the leads, guys. It ain't nothing too major here going on right now. I'm just forming the leads, trying to get it in there to where it'll stay put. Alright, now we find our new capacitor that I just promptly dropped on the stupid floor. Did something with it. Almost run over it with the chair, and then I'll pull the leads out of it. Remember what I did with my spaghetti? Alright, got my little spaghetti right here. This stuff is valuable. Great stuff, man. I think I got mine off Amazon. You get it 2 different sizes. Figure out kind of how big the leads are I need. Remember to put all your stuff back in like you found it. Kind of guesstimating here on where this thing needs to go here. Sometimes what you can do is put the component in there kind of where you want it. Take your marker, just mark the end of the lead where you want it to end. Now you can take it out and cut the right length. The ink it's not going to affect. The length is not going to affect, or the ink is not going to affect the solder. Alright, got that done. Put it back on there. Let's see if we can get this going here. Got to go in. Got to find my needle nose again. Man, I gotta get y'all in frame. I gotta get make sure I'm not in the frame where y'all can somewhat see what the heck I'm doing. But also gotta get the light where I can use it, but to keep the light out of your face, out of the way. When I'm trying to juggle all these variables here in this shot, I mean, I don't think Steven Spielberg could do this. Alright, got that down there where I can solder it. Looks good. Now let me clip that lead. Best practice is to put your needle nose on the lead you're cutting, and then cut the lead. That way it doesn't fly off and you forget about it, and it's inside the radio, going to cause you a short and blow up your radio. And also, there was a lead I cut a few minutes ago. There, oh, that wasn't it. It disappeared in this radio. It went down in this area somewhere. So I got to see if I can dig that out. It may have fell out already, but I got to make sure that it's not in there. Anyway, let's continue on with the replacement cap. Remember, try to put stuff back like you found it as far as lead placement, orientations and all that, because these little radios, it makes a big difference. I can tell you some of these radios, I can't believe they even work. Like that Atwater Kent that I redone. I just couldn't see how so much stuff going everywhere. It just couldn't. It's amazing this stuff even works. But if you can, you know, try to do exactly what they did. Sometimes you put a lead in the wrong place, it's going to affect the operation of it. Like especially in the RF circuits. Putting spaghetti tubes on so I can put this back in there and we can be done with this capacitor. The other thing about these little small chassis like this right here is trying to find a place to put the filter capacitors. Alright, got that in there. As a matter of fact, let's stop a minute. Let me look at this schematic. Where I'm putting that 047 right now, that's where I need to put the 80 microfarad capacitor on that lead right there. Yeah, I've got to do that right now. Also, I've got to double check. I forgot about the tuning gang. I may have to do something with that tuning gang too. Let's just get it operational, then we'll worry about all those particulars. Anyway, let me find my 80 microfarad. That's the 47. Got an 82 at 160. That should be adequate. Good news about this electrolytic, you don't have to find the outer foil. So I got to find the ground of the electrolytic. And it's grounded somewhere in here. Let's see. I'm just trying to find the grounds. Not really up for this today, honestly. Okay, that's the one section. Yeah, it's got a ground right there, if you can see it. So I got to find another source for the red wire. I got to find somewhere in here to put this 80 microfarad. The 80 microfarad. That ain't it. That ain't it. Where's that 80 microfarad go? I think that red wire. Yeah, that's the let's see. Nowhere to ground that. That looks right. Let me stop you, and I'll come back when I get all this done. All right. Run into kind of a snag or a little wrinkle in this little radio, and that's locating the electrolytic capacitors. The original was right here. However, using two radio lead electrolytics right here, I wanted a better place to mount them, and if I mounted them over here, I'd have to extend leads and all this stuff. I'd still have to mount a terminal strip somewhere, but I didn't want to solder to the chassis because I just didn't want to. I wanted to use the existing leads right here. So here is the 80 microfarad, and here's the 40 or the 50 microfarad lead right here. So what I've decided to do is I took one of these barrier strips here, cut one end off of it, and I'm going to utilize this screw hole right here in the side. So what I want to do is take this guy and put it in here about like that right there, if you can see it. I should be able to put my capacitors in there where they would fit. But the problem is, with it like that right there, it's in the way of that screw right there. That screw is the tuning gang capacitor, where it's got the grommets. The grommets are going... I gotta look at those grommets. I'm not sure what shape they're in. The capacitor is off just a little bit, but it ain't off a lot. But it does affect the geometry of the dial. So I'm going to have to look at that, which means I've got to stop the capacitor treatment for a few minutes or a few days, which is really not hard. Just take off this lead, that lead, which is, as you can see, it's corroded too because of that wire. I'm going to have to replace that. Let's see what else is on here. I think that's all. So I'm going to have to do all that. I'm going to have to make a note of the tuning string here and all that good stuff. course, on this it's not very vital. All it needs to do is turn back and forth because the pointer is attached to this right here. So I'm going to take that off and look, see what I can do to strengthen that up, get this situated, and then I'll come back to the, we'll finish the capacitors. So let me see what I can do with that. Alright guys, I got the tuning capacitor out, or tuning gang, should I say. Alright, and yes, I had to cut another lead off another capacitor just to get to this. Got some little fuzzy dogs here, a little bit of fuzz. No big deal. I'm considering if I want to put this in the ultrasonic with a tiny bit of citric acid, a little bit of dishwashing liquid. Let it run a few times and get it nice and pretty. Really thinking about that. And as a PSA, this right here is not a handle. You don't go and pick that up by that. If you do, you'll get what you'll deserve in that endeavor. Well, here's the rubber right here, and the rubber is actually not bad. Still a little supple. Got a lot of give to it, not a whole lot of give. It's not all gooey and meshy. So I'm debating if I want to even mess with this. That has a barrier strip under it. Come on, get out of there. I'm thinking I'm going to pull this dude off. That's really spooking me. I'm going to do that, possibly take the speaker out. It's a lot of stuff in there, man. All compact. That's the capacitor right here I had to cut loose, and it came from right here. And then here's the other one here, which means I got to move this barrier strip somehow or another. Enough to get that out. Like, is it really worth it for what I'm about to do? Alright, I got them out. Now I should be able to pull the rubbers out. Excuse me, the grommets. Use the right language here so I don't sound like I'm completely 100% Winfield in. Yeah, that one tore. Kind of like I figured it would. Got some of these somewhere. Honestly, I think you can just go back in with some rubber grommets, and guess what? I got Harbor Freight. Excuse me, Harbor Freight is your friend. Yeah, it's all torn. These are very tired. So I'm going to pull the loop assembly off. I'm going to take the speaker off, so that'll be safe, and then I can go ahead and clean this chassis. While I'm at it, I'm going to not 100% sure what that is. Some kind of clean this thing up a little bit in the ultrasonic, give it a bath a couple of times, see if we can make it pretty. Clean the chassis up, change what capacitors I can, then put this thing back together. So anyway, that's what I got to do. Bring you back.